So again, I'd like to thank you for the time you're going to be spending with us. My name is Mark Gatiss. We'll also be joined by Rob Neave, CTO and co-founder here at Nlyte. If you have any questions during today's webinar, please submit them into the question box and we will try to get to them at the end. We tend to run pretty fast webinars here at Nlyte. We try to keep them to 30 minutes. We have quite a bit of content, and based on the number of people who are on this webinar, we should get quite a few questions. So my guess is we'll be hard-pressed to get it done in 30 minutes, but we will attempt to do so. So without further ado, we're going to jump into the webinar here. A quick agenda. We're going to give a quick introduction to who Nlyte is, in case you aren't familiar with us. We'll then talk really briefly about the risks posed by power outages. I think there's been some news recently out in the press regarding power outages, in a large part due to the Delta outage, although they are not unique. We'll talk a little bit about the risk posed by power outages, and then I'm going to turn it over to Rob, and he'll talk about 6 ways you can really assess your power chain risk and really mitigate any risk you have of the power chain within your own data centers. And then we'll talk about 3 short case studies focused on this area. And then, as I said, we'll get to the Q&A. So without further ado, let me introduce Nlyte Software. Nlyte Software has been in business over a dozen years. We literally have hundreds and hundreds of customers who use our software solution to help manage and automate the management of their data centers. And as you can see, here's just a very small partial list of our customers. They come from a wide variety of industries and a wide variety of sizes. But what they all have in common is they use Nlyte to help manage their data center infrastructure. And so what you're seeing on the screen now is a variety of different screenshots, because a picture is worth 1,000 words. This will give you an idea of the types of things we do, but really, Nlyte helps companies manage racks, servers, cabling, power, the workflow that occurs within the data center, the processes, the audits, the compliance initiatives, the power, the resources, the heat maps, everything that's involved with managing a data center. And one of our strengths is Nlyte Software helps an organization manage their entire dock to decom process, meaning the entire life cycle of the data center. We take from when resources or equipment comes into the dock, we manage getting it installed, its life cycle, the tech refresh, and ultimately the decommission, what we refer to as the dock to decom process. So we handle a wide variety of processes within the data center. But today we're going to focus on power. We're going to focus on power outages specifically and how you can mitigate the risk. And they're more common than people think, right? I was actually talking to an industry analyst recently who actually said that many CIOs are actually negligent when it comes to their power chain. And it isn't that, they're intentionally doing this. They just assume, sort of out of sight, out of mind, that the power chain is going to function. And that what you're finding is that many organizations have invested heavily in hardware, but they don't have software that sees across the entire data center or set of data centers. And so they don't see things holistically. And so as they look at things in a silo fashion, there's risk that is occurring on a holistic basis, but they don't see it because they're looking at things from a silo perspective and not using software to its full capabilities. And they really lack that clear visibility into the infrastructure, often until it's too late. And many companies, taken out of sight, out of mind, will wait for an alert, but often when an alert occurs, it's too late. You're already into serious issues that can cause a cascading effect. And so I think often we see a lot of these. Delta's not alone. There have been a variety of different outages that have gone public, but there are a lot we don't see, right? There are a variety of companies who have power outages that never make the news, but pose a certain amount of risk. And really, when you get down to it, hardware vendors will tell you, well, you need more hardware, and that actually can make the issue worse. That can increase the complexity of the data center, and it also can make data centers more fragile as you add more potential hardware, may not make the situation better. And I think we've all seen the potential ramifications to an organization's business. When you have these outages, they can literally destroy the brand and reputation of an organization. They certainly can cause loss of service, as we saw recently on Delta, and we're certainly not trying to pound on Delta. They are not alone by any stretch of the imagination, but it's the one that's most apparent and we saw recently. And another ramification is you can lose customers and customer loyalty, and ultimately reduction in the market value of an organization, and people can lose jobs within the company or within the data center from these types of events. So although the power chain is often sort of back there and people assume it's up and running, there are ways you can mitigate risks. And we're fortunate today in that we have Rob Neve, our CTO and co-founder here at Nlyte. We're going to talk about six very specific ways you can go assess how fragile or how solid or how hardened is your power chain. And so thanks, Rob, for joining us.
Yeah, thank you, Mark.
And so without further ado, I'm going to sort of turn it over to you and let you sort of take it from here.
Okay. So I guess the first one, which, I mean, in many organizations, they're probably under the assumption that it's already documented in some way, is really documenting the power chain, understanding how the power is distributed from actually when it comes into the building, the connections through the UPSs, down to the PDUs, down to the back of the servers, into the racks, fully understanding that power chain, documenting it all the way through. So, and this may sound like common sense, so that they can understand, or you can understand as a business, when I lose something in that power chain, when something is at risk, or when something has to be managed or maintained, I can understand the impact of when I take that power chain down, or I am working on a piece of the power chain and not, you know, affecting IT or basically affecting the service that the data center is providing. So it's really understanding the end-to-end points of the power chain, all the equipment involved in that power chain, the age of the power chain, and how it's distributed across to the IT devices. And that's not in spreadsheets or like homegrown systems or documented in a book somewhere. This has to be in a system somewhere where you can search, understand the connectivity, and understand the age of each of the pieces.
So why is that important, the sort of power? Like what do you get out of that?
Well, the initial thing really of understanding how it all fits together, if we just take all the age of all the pieces, so all the devices, so the different parts of the power distribution, if we understand the age and the maintenance periods and when they were last maintained, when the warranties are up for each of these devices, that in itself is a very valuable piece of information, as we've seen in IT when we're doing tech refreshes. But from a facilities side, it's really key to have that information because this equipment ages, it's under stress, and it's also worth understanding, or it's very critical that you understand, that if I do need to maintain this piece of equipment or this piece of equipment has to be changed, understanding what that equipment is feeding. Understanding that if I take this power distribution unit down or I take this power supply A down, that potentially I'm going to risk an area of the business, and maybe we could lose service.
Okay.
So the next real piece is understanding what that power chain is doing, how much energy is being used, where that energy is being used, and who's using it. Now, many organizations will have a BMS system, some type of internal monitoring solution within inside the facilities world that's looking at the power that's being used or looking at the air conditioning inside the environment. It will be looking at that kind of data, and they will have many different distribution or BMS systems throughout their organization across their campus. These BMS systems are going to be very silo-focused on the building or the data centers that they are looking after. What we need to do and what you need to have is a view, a single pane of glass across all of your infrastructure, being able to see that real-time information flattened out across the vendors, so that you can see exactly what is being used, what energy is being taken within inside each environment, the health of that data center. So if there are risks, if there are alarms, or there are things going wrong within your campus, being able to see that in one single pane of glass. Not locked into a specific, if you like, vendor or type of infrastructure where you can only see within a certain building, just being able to see across it all. It's very important to see that because if there are areas where you're overloading or underloading, or there are areas of risks, being able to identify those risks before you move service to those areas of the data center.
So obviously this webinar has a lot to do with power. So are you getting everything you need in power from the BMS system? Like, does that?
BMS, well, it really depends on the type of BMS that you have running and how far you've deployed it. So BMSs will give you some information. What they'll do is they'll tell you this is the energy or whatever's being used within the building. What they typically won't do is take that information down to service. And what I mean by that is they won't understand the relationship between the power they're providing and the IT devices that they're consuming that power, and then from there, the service that those IT devices are providing. And that's where at DCI, and that's where we fit in really, is to give you that mapping. So you can see this energy is being used by these IT devices and by these services. So if you do have an outage or you do need to plan for an outage, you can understand this is what's going to be affected straight away.
I mean, when you're talking services, I'm assuming that ultimately there's some application.
That's what I mean by a service, yeah. Sorry. So,
Yeah.
What I mean by a service really is the application of what you're delivering to your business. So whatever apps you're running inside your business to provide your business, and really that's what the data center is for, it's understanding how those services map to the physical servers that map to that physical infrastructure. And it's as simple as lights on, lights off. Switch the power off, the light goes out. And it's exactly why you need to have that mapping or that understanding inside the data center.
Okay, great.
So the next one's power failure simulation. And really there is, and I'm pretty sure most, if not all, data centers will be doing testing, they'll be spinning up their generators, they'll be doing crossovers, they'll be doing failovers, and they'll all be very nervous while they're doing these tests, because they're relying on the infrastructure and the PDUs and the UPSs within inside their environment. By having everything in a model and being able to see everything more clearly and how everything is connected, you can run failure simulations in production time, because you're not actually affecting the production equipment, and you can see what would happen. Have we distributed our power correctly? Do we understand where everything is? Do we understand, and I say power A and B, which is basically where I'm talking about redundancy inside the data center. Do we understand if we were to switch off power supply A and the load was to transfer over to power supply B, do we understand, can our infrastructure take that load? Now, in the real world, this is some of the outages we'll see out there that are out there, is sometimes it can't. Sometimes they overload it. Sometimes they don't know until they have an outage how bad things are. They have a cascading effect. By having everything in a system, by having Nlyte there, being able to model things out, see the power chain, they can run these simulations daily, weekly, whatever. They can really push to make sure they're absolutely as best they can using their infrastructure that they have.
So this is really about being proactive rather than just assuming the equipment is going to stand up. I mean, this is really proactively saying, all right, let's make that fail, at least simulate its failure, and then see the ramifications.
Yeah, it really is. This is all, this whole piece about understanding what you have, getting it all together, documenting it down, running models, running scenarios. It's all proactive. Typically, you know, as we've seen, and as you were saying with many organizations, typically this can be a reactive step. So turning this to a proactive can really turn and increase the resilience of a business.
Right. But as you said before, if you've mapped everything from, you know, the power to the devices up to the services or applications that are running, I would imagine in some circumstances, some services you don't care if they necessarily have redundancy, right?
There are non-critical, yeah. There will be non-critical services, and there'll be non-critical applications, and there may be R&D and test lab areas that you decide they're all sacrificed straight away to keep production up. But even those mappings, if you don't have those documented, you don't know which ones are critical, which ones aren't. If you go into a data center and you've got yourself 500,000 servers all laid out, and they're all powered up, and they're all back to the power chain, understanding which one of those servers or which parts of the service are sacrificial, unless you have it documented, unless you have it in a system, unless you're able to search through that system quickly when you need to, you're just gonna do the best you can. Right. So you really need to have it in a system documented. And you really need to run these power failure simulations. You really do need to see, if we had this, what would fail, what would survive, what
So
would
how often would you think people would want to do power failure simulations? Like on a monthly basis, or I mean, what do you?
Yeah, I would say a monthly basis, practice with the NOC, do a failover, see everything that works, make sure your documentation's up to date, make sure you have a process, make sure you have a process for understanding if we were to fail and we simulate and we fail when we look good on our failure, how would we recover? Build your recovery plans, document your recovery plans. And this is the other thing, by having everything in a system and everything in one central place rather than distributed in little sheets or in some person's head, having it all inside a system, being able to run reports and documents and processes and wrap this whole infrastructure around a procedure, you're able to deal with recovery. And then if the worst does happen, you have a plan. You're not all running around trying to figure it out and losing money and reputation while you're trying to figure that out.
Okay, great.
So this really does bring us into in another industry, the IT industry. In the IT industry, over the last, 15 to 20 years, it's really hardened itself up around processes and procedures and working together and documenting and everything, really being able to deliver IT as a service, and that's ITSM. So that whole service is there. So what you need to do is bring that facility side information, that what's going on inside facilities, the incidents and the outages, you need to tie and bring that information into ITSM. The benefits with inside ITSM obviously are that you can look back in time. You can build on your procedures, you can learn what you've done, and you can make things better. And you can deliver a service really quickly, and you can understand and agilely move forward. Facilities needs to move that way. So the documentation of when there's an incident, when there's a plan change, when there's something going on inside that data center needs to be documented and communicated into ITSM so that everybody is aware. Because sometimes it may be IT load has suddenly gone up for whatever reason, a whole new load of IT equipment's been added. Facilities were unaware of it, we've now overloaded that power supply A, and we've potentially caused this issue. So we need to share and push that information from facilities into ITSM and pass that across.
But why is that valuable? It's great. You're taking those issues, those incidents, you're moving them into ITSM. Why does it help make the power chain more sort of solid?
Because you can understand, is there repeatable things going on? Are we overloading certain areas of our data center? Are we putting certain parts at risk? Are we not informing facilities? Are we not providing the load or the power that's required in a certain area? From our simulations, are we seeing that potentially a building or a phase within a building is completely overloaded? So we're seeing that in our simulations, but if we're not communicating that through to IT and we're not communicating that to the load that's being added, then it's all getting lost. And then you're going to still be adding to that risk. So documenting in ITSM, sharing with ITSM, pushing and really bringing facility information and facilities team into the ITSM flow and understanding and documenting it really does help, because then you can look back in time.
I mean, it sounds like with these first four, there's a lot about transparency, right? Making sure that all the different layers are communicating with one another and you can see what's transpiring across all four of them, all the different components, right?
So, and that really is it. So if you understand and you've got everything documented and you've brought everything into the system and you're able to understand what's being used, where and how, you're able to do real deep analysis. So you're able to look at, well, the energy within inside this environment is being used, and it's being used by these areas of service, and it fluctuates at this rate, and there's these patterns and trends that are forming inside the data center. You now can get proactive around your distribution, around your infrastructure, around the service areas, the maintenance areas, the areas of risk. You can really be proactive and start pushing to deliver a better service. And it removes risk from both areas, really. And I know everyone sees it kind of like as an IT and a facilities, but really today it has to be a service. And it is a service from the facility all the way up to IT. The silos have to be broken down for us all to work together together to deliver that service, because we're all affecting each other. Facilities, obviously, if the lights go off, that's it. You know, if there's no more power, there's no power, there's no more IT. And if IT is adding more IT and the facilities aren't knowing about it, it's really about joining the two together, sharing the information, enabling facilities to understand what's coming and what load is potentially going to be added, and IT enabling what load and power they can use. And if there is incident, being able to be aware of those incidents, not written down in a document or hidden in an email or whatever, being able to actually see that distributed through.
Are there trends you have to look for that actually aren't issues themselves, but are sort of growing as potential issues, but they don't cross a threshold to throw off an alert? Are there trends one should be looking for in terms of power that could potentially have an issue in the future that you'll see more in a trend analysis?
Yeah, that you may see, if you're looking across the power distribution inside your environment, you may see, the prime examples are, you may see overloading of phases. So there's, i.e. equipment all being pushed to one end onto one phase. So you want to try and keep your data centers, you're trying to balance the phases. So you've got your multiple phases coming into the data center, that's how your power is distributed. You're trying to keep that balanced. You don't want everything going on one phase because then you're at risk, as well as the cost, you've got the risk. So you're trying to keep everything balanced. So if you see a trend where all the equipment is starting to move that way, that's one thing to be looking out for. If you're looking for patterns within the power draw that are just not normal, if you're looking for small fluctuations or facilities area of PDUs or UPSs that are just fluctuating out of norm, then they are potential areas where either maintenance might be needed. So maybe you need to investigate, are things of good health within inside your infrastructure? Are there areas there where we need to start looking? Maybe a potential of a circuit or something is about to break. You've got to remember, these are machines, these are high plant machines, lots of voltage moving through them. They will fluctuate when things are not right, and they will break like a car. So you really need to be looking out for these patterns and seeing when things aren't right. And by monitoring everything, you can see it across all of your data centers.
Well, it sounds like the bullet number 2 had a lot to do with real-time monitoring, seeing events as they occur in real time. This seems to be the counter of that, which is it isn't just about real-time events, it's also about seeing events that are building and seeing potential issues that are occurring over time that only in the macro do you actually begin to see.
Exactly, and the only way you're going to see that visualization or understand that is to centrally bring that information together so that you can historically look across time. By having siloed information, and this comes back to the BMS. There's many BMS systems out there, and they'll all be inside your campuses, all working in your different data centers, and they'll be storing and capturing some information. Having all of that information in one place where you can look across the whole campus, across all the BMSs, across all energy, and across the health of your organization, it gives you that one view of everything, that single pane of glass where you can see these patterns.
Great.
So this one really is, and this is a very frustrating, I'd say, that's a nice way of putting it, a very frustrating area really, which is around the security of the facility infrastructure. And when I say security, if we look at IT security and the way that IT, we have firewalls, we have security scan software, we have very strict procedures, we have a team that's dedicated to looking at the security and the health of IT and how secure IT is, to really make sure no intrusions or anything bad can happen to IT. Now, we've focused a lot on that in the last, 10, 15 years, really higher pressure. An area which has really not had the same amount of pressure on the same views is the facilities network infrastructure. So the facilities side of things, we've talked about the power chain, but each one of these devices on the power chain connects to a network. Each one of these devices has things called consoles or computers, terminals, where people are just going on and they can access, they can shut down power, spin up power, transfer load. They can control those devices from these different distributed consoles, and sometimes little tiny hardware devices that are just sitting on a network. Someone can remote in from somewhere to move the power up, move the load or whatever. These facilities type infrastructures have fallen outside of this IT security area. They really, you know, they'll have passwords that aren't checked. They'll have OSs that are running, operating systems that are running on them that aren't up to date. They will be running the oldest version of the software. They're, you know, even the access of who can get to these consoles, who can actually go in, control the building infrastructure, shut down the building infrastructure. Having that information and being able to do it is, you know, it could be anyone. It could be passed on to a friend of a friend inside an organization. It could even be an external contractor that has access to this area, you know, who can just go in, they can work on their terminal, but sitting right next to them is another critical terminal that could shut down the whole building. This security area is something that needs to be looked at, needs to be brought in, and needs to be documented and needs to be controlled. And this is where joining into ITSM, joining into the IT security protocols and procedures really will help, because this is the potential time bomb that's in.
This especially seems risky, given that in most data centers I've been in, there are contractors walking around with and who've been given some amount of access. And I know at the beginning of the year there was a data center failure that wasn't attributed to a particular employee, but it was a contractor's systems had been hacked, and then through that information, the hackers were able to get into the data center. So I think you're probably right that at this level, nobody's maybe looking at the power chain and understanding what the risks are. And you'd indicate a lot of these devices are just on open networks.
They are
right?
completely
Although the power chain itself is not on the network.
No,
The
devices that control are. So, and as we move more towards our IoT, and as we move more to the software-defined data center, and as the data center and the software and the facility and everything starts joining together, this really is the bastion that needs to be controlled, and access needs to be controlled too, because this is the area that is the actual controlling. These software, these pieces of devices out there, these terminals, they are the devices that can shut down your data center. They are the devices that spin up your UPS. These are the devices that can move, load, and transfer load. These devices, you know, the simple question, when was the last time the passwords were changed? When was someone last go around and do a firmware update or a software update on these devices? Where are all these devices, and who can have access to all these? Simple questions to answer, but they need to be documented and modeled within inside that power chain.
Great. So there are 3 case studies here, and you can sort of add color if you'd like, Rob. I'm sort of going to go through them pretty quick because we're running out of time and we're getting quite a few questions. But all these companies, as I've mentioned before, Enlight provides robust capabilities, but one of our solutions is called Enlight Energy Optimizer, and all 3 of these customers used Enlight Energy Optimizer. In the case of this large financial services, when they deployed Enlight Energy Optimizer, we affectionately call it NEO, they immediately identified that one side of the power chain was just overloaded, the A side. They'd somehow wired things up so there was just too much flowing into A and not enough going into the B side, right, which they realized put them at risk. So immediately they were able to identify that and then obviously rebalance the load. So the challenge with any time with this type of risk is it's the event you don't hear about, right? There's a value to that, but you never hear about the bad thing that didn't happen, right?
Yep.
And so in their case, they were able to head off a potential server issue. On the other side, I'll jump over to the mid-size e-commerce company. It sounds like they did the same analysis. They implemented NEO. They determined that their servers were properly balanced, right, that there was redundancy, but they didn't have redundancy at the network level, right? So
let me explain that. So they've done exactly the same. So they'd actually identified where basically, and it was just because they didn't have the joining, they hadn't joined the facility load information with the IT distribution or placement of device information. So, and the large financial, when they joined it all together, that's how they were able to manage and transfer and start directing IT load to the other phases. From the e-commerce company, what they were able to see was, okay, we've got resilience, we've worked out redundancy in our IT devices, fantastic. But what they had documented or didn't have the understanding around was the network devices and the distribution of the networks. It was all great that the IT, the servers, the storage was all running, but what they found was that if they did have a failover, and if they did simulate failover, they could see single points of failure within the network infrastructure. So then they were able to really distribute the network infrastructure slightly different, and then provide more of a resilient load to those areas.
Right. And then this third one, the large service provider, it seems like they implemented NEO, and they began to sort of monitor their branch circuits, and they were seeing power fluctuations. And at that point, we're able to identify these circuits are at risk because we're seeing fluctuations. And then I guess...
Yeah, they were literally, because they were getting the information, it was less than a minute, they were recording the information, they were seeing like a harmonic load across the PDU, across the backplane on the board. They could see that something wasn't right. It was a load, there was a pattern forming, and it was a continuous pattern. They then got their maintenance people to come in, they looked at it, they were able to do a deeper analysis, and they realized that that PDU needed to be taken off load, and some maintenance needed to happen, and then they put it back on load. But it gave them that proactive approach to actually see and help identify there's something that could potentially happen. Nothing did happen, but it was something for them to see that there's a potential risk here. Let's do the next level of investigation.
Yeah, well, it's always the thing that didn't happen, right? It's
the tree
that did not fall, right? In this case, with these three organizations, they avoided potential issues. Who knows what the ramifications might have been. So we're running out of time here, and we've got a variety of questions. We want to get to some of them. The key takeaways here, I'm not going to go through all the details here. I think if you were on the webinar, really a lot of this is about transparency, right? It's being able to see from down to the concrete all the way up into the stack, into the applications, into your ITSM system, making sure all systems are communicating with one another, and you have transparency in real time and in trends across all the different systems you depend on, and making sure that your power chain is completely secure and hardened. And so we have a variety of assets here we're going to point to. Feel free to download our Data Center Infrastructure Management ROI infographic. We also, on the Nlyte website, have a webinar specifically focused on the 5 key metrics to consider when you're doing real-time monitoring and alarming of power. And there's our email addresses. We also have DSIM for Dummies if you'd like to take a look at the DSIM for Dummies book at the Nlyte site. But at this point, we have a variety of questions, so I'm going to sort of turn to the questions we've received so far. Well, the first one's sort of pretty easy for us, right? We are already an Nlyte customer. Do I have this? And I think when they say, do I have this, they mean...
It already is.
Well, do they already have the functionality provided by NEO?
No, NEO is a separate module, a separate system, basically, that connects to Nlyte Core, so Nlyte Enterprise as it would be known. There's a licensing up change on both, and then you can literally bring the information from NEO into the Nlyte system and directly in, so you're looking across one pane of glass across the joint solution, and then that information can obviously be shared up into ITSM.
Right. And I think this one you may have touched on, but I'll go ahead and say it. How can Nlyte help with power recovery? I think you sort of touched on it lightly during the webinar. Why don't you sort of...
So because you have to, if we fast forward, imagine you've got Nlyte installed, you've got NEO installed, you're bringing the information in, you've tied all of your network connections together, you understand how the power infrastructure is distributed and the IT devices and the services it's delivering. You understand how it's all connected. You can automatically run, and there's a number of pre-canned reports inside the Nlyte system that you can run that are recovery reports or planning reports that will run across the system. They'll tell you all the affected devices, the business units, the support units for those devices. It'll tell you exactly who's going to be affected. If I lose this power supply, who would I need to call? You can use those as your recovery plans or your planning for if you need to do planned maintenance.
Okay. Next question is this in ServiceNow? We have that. You'll have to interpret.
No. So ServiceNow, you've got the ServiceNow FM system, they call it the facilities management system. That system is really around, I'm the person sitting at my desk and my desk light keeps going out, or the fan above my desk is blowing too cold. It's really like a little floor plan where someone who can sit at their desk can just literally say, where I sit is not so nice, or I've seen a mouse, or whatever. They can put and post a ticket with inside, and that'll go through to the facilities person, who will then know, because you've said on where I sit at my desk, this is where I sit, that's where I saw the mouse, or that's where the fan was blowing too cold. Absolutely nothing to do with the data center. It doesn't even go into this area of business. It does what it does. So the FM and the CMDB and the ITSM systems, they are a different type system than the DCIM, DCSM. Really, facilities, understanding what's going on in the power infrastructure, monitoring, joining it all together, that's what we do. That's how we fit together.
Well, we have a variety of customers who integrate with ServiceNow.
Oh,
we have ServiceNow connectors, right? And they want that
yeah.
information in ServiceNow, correct?
Yes, certainly. So all of your assets, all of your asset information, this is the other benefit. When you've documented your power chain, you've documented how it all relates to the IT equipment, and you've tied Nlyte using a connector, so it's not an integration, it's a standard drop-in connector, and you've tied Nlyte's assets to the CMDB CIs, you've now joined the whole end-to-end. You've joined to the service or catalog item that's being delivered within ITSM through the CIs to the assets within Nlyte to the facilities load and the facilities power infrastructure. Now you fully understand, if I switch this off in the data center, if I press the APO button, if I power off my data center, this is exactly what I will lose. These servers, this service, this part.
This goes back to your point. One of the 6 bullets was integrating with ITSM, so you have all that transparency and visibility, right?
Correct, yeah.
Great. Hey, we have run over time significantly. We usually like to keep these at 30 minutes. For all the folks that submitted questions we didn't get to during the webinar, we will get back to you individually. We assure you we will get back to all the questions we did get. We got quite a few, so we will get back to everyone that did submit those questions. Again, thank you for the time you spent with us during this webinar. We look forward to seeing you in future webinars. If you happen to be at DMC Engage, please drop into the Nlyte booth, or come and see myself, Mark Gatos, at the Data Center World. I'm going to be presenting on a panel at Data Center World in New Orleans. If you're there the second week of September, drop in. Thanks again, and we'll see you on the next webinar.